from
negative infinity to 1.
Excellent. Union.
And 1 to infinity.
That's it. Great job. So all these items will be given to you. So a max min, there is none. Range we determine, symmetry we determine, so everything is there. Don't forget the y-intercept. We already calculated it and we put it in. The y-intercept 0, negative 1/2. This is it. Yes, it takes a while. It's not a trivial problem, but I think we should move on to type 2, which is easier even than this. So let's make some notes about type 1. The first note that I would like to write is this. All type 1 have a horizontal asymptote y equals leading coefficient over leading coefficient. So for example, if I give you the function 4x squared minus 1 over 3x squared plus 4, and I ask you, does it have a horizontal asymptote? You will say yes, it's type 1. It has a horizontal asymptote. It's the same degree of a same degree, type 1. And what is the horizontal asymptote? What will you answer?
4/3.
Thank you very much. The horizontal asymptote is 4/3. If I give another example, let's say f of x equals negative 2x plus 1 over x minus 3, the horizontal asymptote will be
-2.
very good. Leading coefficient over leading coefficient. Be very careful that if these are twisted and they are not presented in the correct order, you have to rearrange them before you identify the horizontal asymptote. Okay, so we'll come back to type 1 with another problem, but let's look at the type 2. Everything is the same, and I claim it's something even easier. So,
I have a question real quick.
yes.
Sorry, if that was on a test and you just asked for the horizontal asymptote, would we have to write y equals 4/3 or just 4/3?
No, the horizontal asymptote is a line, so you have to write y equals.
Okay.
Yes.
Just making sure.
Yes, yes. So now, for example, this function has a vertical asymptote. What is the vertical asymptote for this function? Very good question, actually. Thank you for asking.
Three.
Yes, but not 3, but x equals 3. And this is the horizontal asymptote. Y equals -2. Here is y equals 4/3. Is that okay? So ready to look at the type 2?
Yes.
Okay, I want to look at, let's look at type 2. A simple one. What type is this?
Type 2.
Why? Why is it type 2? Because the degree of the
Denominator
is
higher.
excellent. Great job. The degree of the denominator is higher. Everything is the same as before. And I'm going to write this down. This is the only difference forever. For type 2, the horizontal asymptote and the end behavior will be 0. So the note for type 2, the horizontal asymptote is 0. Always. Only for type 1. The horizontal asymptote is the leading coefficient over the leading coefficient. For type 2, is always 0. So let's go through the same steps. The first problem took us 15 minutes or more. This one will take us 3. I don't want you to spend, it's an important topic, but I don't want you to spend too much time on this, please. Okay, domain, please. Anyone, please, domain.
Negative infinity to infinity.
Look at the denominator, right? This is not a friendly function.
Negative infinity to 2.
Yes. So negative infinity to 2 and 2 to infinity. Is that clear, everyone? Is that a yes?
Yes.
Perfect. Okay, very good. So now the x-intercepts. Oh, I'm sorry. So let's write x equals 2, obviously, is a VA. We have infinities for sure left and right. What we don't know is the sign. So please plug in 1.9 in the function and 2.1, and I only want the sign. And then I would like to look at a word problem. And then we'll look at type 3 on Wednesday. But I still would like to look at a word problem before we adjourn today. So see how important this is. Okay, so please plug in 1.9 and just give me the sign. I don't want the number. I only want the sign.
Negative.
Of
Negative.
course. Of course. Please plug in 2.1 and just give me the sign. I don't care about anything else.
Negative.
2.1 minus 2.
Positive.
Right? We agree? 2.1 is bigger. So $2.10 minus 2, we still have 10 cents, right?
Sorry, I was plugging in the wrong number.
That's okay, no worries. Okay, so please plug in 0 and tell me what is the y-intercept? When x is 0, f of 0 is?
Negative 2. Oh. Forgot to do the 1.
Negative 1/2. Very good. Okay. X-intercepts, please. How do I determine the x-intercepts? When
Y equals 0.
1 over x minus 2 is 0. We just said a few minutes ago that a ratio of fraction is 0 only when
The numerator is 0.
good. Can the denominator be 0? The numerator be 0? No x-intercept. Very good. We're done. This is it. No symmetry. The range will be determined. We'll see in a moment. Let's graph it. When I graph functions with asymptotes, what do I have to graph first? The asymptotes. So when we graph a function with asymptotes, we have to graph the asymptotes first. So x equals 2.
Can you move the paper up, please?
Yes, yes, yes. Better?
Thank you.
Thank you. So this is x equals 2. There is no need for this one. This is an overkill, but that's okay. I will plot the point 0, -1/2. I'll just follow my table. Let's look at the table. The table says from approaching 0 at -infinity, crossing the y-axis at 0, -1/2, and then going to -infinity on the left-hand side of the vertical asymptote. That's it. On the right-hand side, very clear, from positive infinity to 0. From positive infinity on this side, up there, dropping to 0. And this is it. So this is the function 1 over x minus 2.
When you draw those, I know it's not touching the dotted line, but are you wanting us to touch the actual graph?
No, very good question. Do not copy from the graphing calculator, because the graphing calculator is not as sensitive as and doesn't know what you know. So the function may eventually touch, but we will not make it touch. We will not make it touch any of the asymptotes. Getting closer and closer, closer and closer, but not touching. Okay, we have a few minutes left, and I'd like to look at a couple of problems. This is it. We'll just need to practice this. I would like to look at this word problem. I will not be able to zoom in, but so we are given a function. Can you see here?
What page is it?
It's problem 101, page 428. 101. Thank you. I would have put it down in a minute, but I just want to show you the graph. So page 428.
I can see it, it's just a little blurry, but it's okay.
I can bring it higher. Is this better? Better?
Yeah.
Yes?
It's okay.
Okay, so here's the graph. You notice that it starts here. It has a drop, and then it gets closer and closer, closer and closer to this line. What type of function is it?
The exponents are a little blurry, so we can't really see it.
Is this better?
Can you tell us what the exponents are?
Yes. Yes.
Because
I have to write the function down anyway. So
Okay,
so
yeah.
this is problem 101 on page 428, and we have f of x is 6.5 x squared minus 20.4x plus 234 over x squared plus 36. Isn't this great that we don't get cut off every 40 minutes?
So it's type 1, right?
Yes, indeed. Type 1. Can anyone give us the horizontal asymptote for type 1?
The leading coefficient over the leading coefficient?
Yes, but always make sure that they are in descending order. Are they in descending order?
Yeah.
Very
Yes.
good. Very good. So then the leading coefficient is?
6.5,
And the leading coefficient is?
1.
So the leading coefficient over the leading coefficient is 6.5. So going back to the graph, do we see that this is indeed approaching 6.5 forever? Yes? We forgot to graph this function with the graphing calculator. I'm assuming that you're going to do it. But do not forget to put parentheses around the denominator. You're not going to graph the function we need to. Okay, so I'll stop in a minute, but let's just answer one question here. So what happens to the function, as you see, it drops to a minimum when 6 minutes later we're going to read the question, and then it comes back and levels off. So this function models the pH level. of human mouth, X minutes after a person eats food containing sugar. The graph of the function is shown in the figure. Just the first question and we'll stop. Use the graph to obtain a reasonable estimate of the pH level of the human mouth 42 minutes after a person eats food containing sugar. 42 minutes? I'm going to say approximately pH level is 6. Can you see? So 42 minutes, approximately 6. So I will say for the function, from the graph, X equals 42 minutes. F of 42 equals 6. pH level has no measurement unit.